Okay, this is the second lesson that we need to look at, which is also a review of polynomials. We've added and subtracted them, we have evaluated them. Now we need to multiply and divide them. So if we're going to multiply polynomials, we need to use the distributive property and then simplify by combining like terms. So this is going to entail the things that we learned in the first lesson. When we distribute, that's going to be the same thing as multiplying. So we're going to need the rule that when we multiply like bases, we add the exponents. And we also looked at combining like terms. So for the first problem, if you remember back to the last lesson, we have a monomial, the negative 2x squared y, times a trinomial. So what we need to do is distribute this first term times each one of the three terms. Now there are multiple ways that you can work some of these problems, and really it's whatever method that you're comfortable with and feel like you can be successful with. I'm going to, since this is our first problem, I'm going to actually write out what I'm going to distribute. You can do that if it helps you. If you don't need to, you can begin distributing automatically. But the first thing I'm going to do is multiply that monomial times the first term in the trinomial. I always put a plus so I don't have to worry about the sign. Then I'm going to multiply that same monomial times the second term in the trinomial. And then I'm going to multiply that monomial times the last term in the trinomial. So if you don't show this step and you just begin the distribution, that will be fine as long as you're comfortable with that and able to do it successfully. So if I look at my first multiplication, I have negative 2, and since there's not a coefficient in the second parentheses, that's the same thing as negative 2 times 1, so that's going to be negative 2. Then you notice that each one of them has an x variable that is like bases being multiplied. So we are going to add those exponents, 2 plus 3, and then we have the variable y, and that's y to the first times y to the second. So we're going to be adding 1 plus 2. And then we're just going to repeat that for each one of the multiplications. For the next one, we have negative 2 times 5, so that's negative 10. For the like base x, both of the exponents are 2, so we're going to have 2 plus 2. And for y, both of these exponents are 1, so it'll be 1 plus 1. And then in the last multiplication, negative 2 times negative 3 is 6. Each one has an x variable that's being multiplied, so it's 2 plus 1. All we have is a single y, so we just bring that down. And now all we have to do is clean this up. This is negative 2. X to the 2 plus 3 is 5. And y to the 1 plus 2 is 3. Negative 10. X to the 2 plus 2 is 4. And y to the 1 plus 1 is 2. And then we have 6. X to the 2 plus 1 is 3y. And then that is the final answer. Now for the next problem, you notice each parenthesis has two terms, so this is what we would call a binomial times a binomial. There are three methods that we normally teach for multiplying these. The first one you've probably heard before, is using the acronym FOIL. The only thing about the FOIL method is you have to keep in mind it only works for a binomial times a binomial. So it only works in this one case. The other two methods will work for any two polynomials being multiplied together. We can always just use the distributive property like we did in the first one. And this isn't really an official method, but you can use what we like to call the box method. So I'm going to try to work through the next few problems and kind of demonstrate the different methods. I will never ask you to demonstrate one in particular. You'll always be able to multiply them by any of the methods that you're comfortable with. So don't worry about if you like one better than the other. You can always use the one you like. So if I look at the x plus 2 times x plus 4, and I want to use the FOIL method, then the F stands for first. So the two first terms are x and x. So that means we're going to multiply x times x for the F. The O stands for outside. So my outside terms are x and 4. So we have 4 times x. The I is inside, which is the 2 and the x. So 2 times x is 2x. And then finally the last are the last two, the 2 and the 4. 2 times 4 is 8. So remember the x times x, we're multiplying like bases. So that's x to the first times x to the first. That does give me x squared. If you note, this is usually going to happen here in the middle, what I call the OE in the FOIL. Those are going to be like terms. So 4x plus 2x gives me 6x. And then we bring down the 8. So that's my answer. You can also use the distributive property. So this time we don't just have a monomial that's being multiplied, it's a binomial. So that means we take the first term in that x plus 2 binomial and multiply it times the x plus 4. And we take the second term and multiply it times the second binomial. So if you notice with this method, what's in the parenthesis is always going to be that second parenthesis, and each thing in the first one being multiplied. So then we just distribute. X times x is x to the first times x to the first. So we're adding x squared. And then x times 4 is 4x. Then we're distributing the 2. 2 times x is 2x. And then 2 times 4 is 8. And you can see that we are coming out to the same thing. We only have one squared term. Those two middle terms are like. 4x plus 2x is 6x. And then we just bring down the 8. And we got the same answer. Now because of space, I'm going to go ahead and just use the box method on the third one so I can demonstrate that. So the box, we're basically going to take the terms that are in the first parenthesis And I'm just going to list them. That's a positive 2x and a positive 3. And the two terms in the second parenthesis, I'm going to list them across. That's a positive 3x and a negative 1. And if I draw a box, then what goes inside the box is just the multiplication of the two terms that are on that particular box. So this first one here is 2x times 3x. So we know 2 times 3 is 6. That's x to the first times x to the first. That gives me x squared. For the second box, it's going to be 2x times the negative 1. So that's just going to leave me with negative 2x. In the third box, we have 3 times 3x. So 3 times 3 is 9, and the x comes down. And then finally, in the last box, we have 3 times negative 1 is negative 3. So you can see the methods are all doing the same thing. It's just slightly different methods. What we do now is copy the terms from inside the box. And again, as we discussed, what's usually going to happen is those two middle terms are going to be alike, so we'll need to combine them. So negative 2x and 9x leaves me with 7x, and we'll bring down the minus 3, and that's the final answer. So if you want to prove it to yourself and you have time, you can use FOIL or distributive property and make sure you get that same answer. But you can always use any of the methods. For problem number 4, I have two variables this time, and a lot of students seem to hesitate with this one when there are two variables. So I do tend to use the box on this one, but you can always use any of the three methods that you're comfortable with. So for this one, I'm going to put the positive x and negative 2y, and then the 2x and the positive 5y across the top. And then we'll just create the box again. Then x times 2x is going to be 2. I'm multiplying like bases. X to the first times x to the first is x to the second. Then x times 5y. So this is the first place people usually hesitate. Remember, we can multiply anything. They don't have to be alike for us to multiply. So basically x times 5y just combines all of them together. So I'm going to write it as 5xy. If you write 5yx, that's exactly the same thing, but we usually put them in alphabetical order. So I used 5xy. For the next box, we have negative 2y times 2x. Negative 2 times 2 is negative 4. And again, we have x times y. So we're just going to bring those down. And in the last box, we have negative 2 times 5 is negative 10. And now we're back to the same variable, y to the first times y to the first. So when it's the same variable, we're going to add the 1 plus 1 and get 2. So if I bring down the terms from my box, just like with the others, the two middle terms are alike. So the 2x squared just comes down because there are no like terms. A positive 5xy minus a 4xy just leaves me with 1xy. We don't have to write the 1. And we bring down the negative 10y squared. And that's the final answer. Or for problem 5, the difference here is I don't have two binomials being multiplied, but I really do. It's just in a different form. You remember, something raised to the second power basically means to multiply something times itself. Well, that's what x plus 3 squared means. It's exactly the same as having x plus 3 times x plus 3. You're just multiplying what's there times itself. So if you rewrite it that way, then you can use any of the three methods that we've already done. So if I'm multiplying x plus 3 times x plus 3, if I use the box, I have x and positive 3 on the side and across the top. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. And if we bring those down, I want you to notice something here as well. Not only are those two middle terms like, you notice that they're also exactly the same. That's going to happen every time we multiply a binomial times itself, which can lead us to a shortcut that we can use if we want. So if I combine those like terms, I end up with x squared plus 3x plus 3x is 6x plus 9. So we have a general formula You do not have to use this. You can always write it out twice and multiply it. We will need to be able to recognize this later, so that's why I'm covering it now. Anytime we have a binomial squared, something plus something quantity squared, we're going to square whatever the first term is. We can multiply 2 times both of the terms, and that's because those two middle terms were exactly the same, so we had 2 of them, and square the last term. So if you look at this problem again with the formula, you see in the place of a is the x and in place of b is the 3. So we can say that the a is x and the b is 3, and we can substitute that. It says a squared, so a in this case is x, plus 2 times a is x, b is 3, and then b squared. And you see what I get is x squared plus 2 times x times 3 is 6x, and 3 squared is 9. So we got the same thing using the shortcut. You can use either one, okay? So for the second problem, the only difference is I have a subtraction instead of an addition. So it also holds for a minus b squared. The only difference is we get a squared minus 2ab plus b squared, so only the sign is different. So if I'm looking at 3k minus 4 squared, then we're letting the a equal to 3k and the b equal to 4. Now notice you don't have to say negative 4, and that's because the formula itself takes care of the signs, okay? So a is 3k squared minus 2 times a times b. Sorry, I'm running us out of space. Plus b squared would be 4 squared. So this is where one of the other rules that we looked at came in. Remember, when we've got 3k all raised to the second, that means we have to square the 3. So 3 squared is 9, and k times itself is k squared. Then we have negative 2 times 3k, that's negative 6k, times 4 is negative 24k, and then plus 4 squared is 16. And of course, if you want to verify that for yourself, go back when you have some time and use the FOIL method, use the box method. Make sure you get the same thing. Okay? Alright, the next one goes back to substituting, evaluating a polynomial function at this time an expression, not just a value. But it's the same idea. If f of x is x squared minus 2x, and we want to find f of g minus 1, this is still going to be a substitution. What we're going to substitute is always what's in the parenthesis. So we're going to substitute g minus 1 for x. So this time, in the place of x, we're going to put that g minus 1. I know that looks a little strange, but just try to remember all it's doing is asking me to substitute that expression g minus 1 for each x value. So where I have x squared, I'm going to replace that x with g minus 1, and then I have minus 2 times x, so we'll replace the x with g minus 1. So you see what we ended up with here. That first term is a binomial squared. So you can use the shortcut that we just learned. If you want, you can just go ahead and write that out as the g minus 1 times itself and work it that way. You can do it either way. So if we need to multiply the binomial times the binomial, if you don't use the shortcut, you can use FOIL, distribute, or the box method. I'm going to FOIL just for time's sake. So the first terms are g times g. That's g squared. The outside is g times negative 1. So that's negative g. The inside is negative 1 times g is negative g. And the last is negative 1 times negative 1 is 1. Now don't forget, after all that work, that we still have to distribute that negative 2. Negative 2 times g is negative 2g, and negative 2 times negative 1 is positive 2. Now all we need to do is collect like terms. So we only have one g squared term. There are 3 terms that have g to the first. So we have negative 1g and negative 1g, that's negative 2g, and another negative 2g, that's going to make negative 4g. And then we have 2 constants, positive 1 and positive 2, gives me positive 3. So again, remember, if it asks you to give the answer in function notation, what that means is at the expression g of 1, this polynomial gives me g squared minus 4g plus 3 would be the answer. Alright, so we're almost done with multiplying. This one is slightly different from the last one. In the last one, the binomials were exactly the same. For this one, you notice that they do both have A and they do both have B, but my signs are not the same. That's the only difference. So if we were to FOIL that out, A times A would give me A squared. The outside is a times negative b, so that's minus ab. The inside is a times b is positive ab. And the 2 last terms, b times negative b, is negative b squared. So when they were exactly the same, the 2 middle terms were exactly the same, and we got 2 of them. But this time, because the signs are opposite, my middle two terms are also opposites of each other. Negative 1AB and positive 1AB are exact opposites of each other, so those are going to add out. And that leaves me with a squared minus b squared. So this is another one of those shortcuts, and it will come up again later when we're working with factoring. That's the reason that we're showing it. If I give you x plus 4 times x minus 4, and you want to FOIL it or use the box method or use distribution, I will accept that. But just notice if you happen to see that they are the same variables and the same number but opposite sign. In this case, my a would be x and my b is 4. So all I would have to do is a squared minus b squared, where the a is x and the b is 4, and I get x squared minus 16. And again, if you want to verify that for yourself, use the FOIL method, the box method, or distribute, and make sure you get the same thing. Okay? Lastly, we have to look at division of polynomials. The first one isn't that bad. If we're dividing by a monomial, this is basically just going to use some of the rules that we just went back over in the first part of the lesson. The second one, where we're dividing a polynomial by a binomial, is not one that's a lot of fun, but I remember you will be able to use your notes on the test, so make sure when you practice you can use your notes to follow the steps, and hopefully you'll also be able to do that on the test. For the first one, when we're dividing by a monomial, all we want to do is rewrite each term that is in the numerator over the denominator. So basically we're just kind of separating it out. And then you remember we talked about what we do if we have like bases being divided, we subtract the exponents. That's basically what we're going to do here. So for this first one, I have 18 divided by 3, where we know that's 6. And then for my x variable, we're going to subtract the 5 minus 3. And for the y, we're going to subtract the 3 minus 2. For the second term, 9 divided by 3 is 3. For the x variable, we'll subtract 4 minus 3. And for the y variable, subtract 2 minus 2. Then for the last term, 12 divided by 3 is 4. We have the x variable, we're going to subtract the exponents 3 minus 3. And the y variable, subtract the exponents 5 minus 2. So now we just need to clean it up. I got 6x, 5 minus 3 is 2. Y to the 3 minus 2 is y to the first. You don't have to show the 1. Plus 3, x to the 4 minus 3 is 1. You don't have to show the 1. Now, what we do have to talk about is y to the 2 minus 2. That gives me y to the 0. And I didn't go over this one in the review, but recall that anything raised to the 0 power is always a 1. So that y to the 2 minus 2 is just 1. So that term is just going to be 3x, because times 1 wouldn't change it. Then we have plus 4x to the 3 minus 3, that's going to be 0. So that means that we don't need the x, because that's just a 1. And then y to the 5 minus 2 is 3. And that is the final answer. The last one is, of course, the worst one. we need to rewrite this as x plus 1, and we're going to put the polynomial under our box. And then there's not a very easy way to do this, unfortunately, but at least it is repetitive. So the process that we're going to follow, we are always going to divide, multiply, and then subtract. All right, let's see what we're going to divide, multiply, and subtract. So for the first step, we're always going to be looking at the first term in the binomial and the lead term of our divisor. So what I'm going to divide is 5x to the third by x. And that's what we just did with that monomial. So this is going to be 5x to the 3 minus 1 is 2. So that number we're going to put over here, 5x squared, because that's what we got when we divided. Next, we're going to multiply that 5x squared times the x plus 1. So if I multiply 5x squared times x, those are same base. We add the exponents, so this is 5x to the third. Then 5x squared times 1 is 5x squared. So that's what we get for multiplying the 5x squared times each one of these terms. So that comes up under here, 5x cubed plus 5x squared. Then what's very important is the next step is to subtract. So you remember we've talked about before, subtract really means the same thing as multiply times -1. So it means we'd want to change both of the signs. We have positive 5x cubed and positive 5x squared. So subtract you can think of as multiply by -1. So if I did that, all it's going to do is change both of these signs to a negative. The reason that we do that is because we are trying to find the answer by whittling this down. If you notice what we have now, 5x to the third and a negative 5x to the third, those are opposites, so they add to 0. So that's gone now. So we have 3x squared and a negative 5x squared. That gives me negative 2x squared. So that's kind of the complete process that now we're going to repeat. So I'm going to bring down my next term, and now we're going to start over. My lead term now is the negative 2x squared. We're always going to be dividing by the x in the binomial. So this is negative 2. X to the 2 minus 1 is just x to the 1. So I'm going to put minus 2x up here. Then we're going to multiply what we got times the binomial. So negative 2x times x is negative 2x squared, and negative 2x times 1 is negative 2x. So that's what comes under here. And then don't forget the subtraction step means that we're just going to go in and change those signs. So now it has negative 2x squared, we're going to change that to a plus, and negative 2x, change that to a plus. So it just changes the signs. So that again, I have negative 2x squared and its opposite, positive 2x squared, so that goes away. Then we have negative 7x and a positive 2x. That leaves me with negative 5x. And we have to do one more time. Bring down the 4. So we go through the process one more time. So this time my lead term is negative 5x divided by the x. So we get negative 5. And remember, anything over itself, so x to the first over to the x to the first, is just 1. So all I get is negative 5. So we're going to put minus 5 up here. Then we're going to multiply negative 5 times x plus 1. That gives me negative 5x. Negative 5 times positive 1 is negative 5. So I'm going to copy that over here. And then to subtract, we're just going to change the signs. We have negative 5x, so that becomes positive. Negative 5, that becomes positive. Now these will add to 0. Positive 4 and positive 5 is 9. The reason we know we can stop is because my lead term now is 9, and there is not an x variable in it, so it won't do me any good to divide 9 by x. So my final answer is 5x squared minus 2x minus 5. We write the remainder as plus 9 over the divisor. So this whole thing is the answer. Now I know that process is a lot and it looks very intimidating. Remember, I am going to allow you to use your notes, so when you practice with your homework, make sure you use these notes, try to follow the steps, and follow along and try to mimic them. Ask me if you need help, and try to make sure that on the test you'll be able to use your notes correctly to be able to work this problem.